Hello everyone, this is part 5 video on past year NEET questions from the chapter Newton's laws of motion. Now those who are looking at this video can also take a look at the previous 4 parts so that you will have continuity of questions. We'll start with a question that has come in the year 2001. A 1 kg stationary bomb is exploded in 3 parts having masses 1:1:3 respectively. Means they are giving us what? The mass ratio. Okay, the parts having same mass move in perpendicular direction with a velocity 30 meter per second. So they are giving only the velocity of the parts having the same mass. Means this one that are having the 1:1 ratio. Okay, then the velocity of the bigger part will be. So this is a question based on the idea of conservation of momentum. So this question can also be classified as a question in the system of particles, but yeah. So in laws of motion chapter also we'll discuss about the conservation of momentum principle. So if you look at what is happening initially, this 1 kg mass is stationary. Means what? The velocity is basically 0, which means initial momentum. What is the initial momentum of that 1 kg piece? It is 0 because the velocity is 0. Now when it is exploding such a way that it is getting into 3 parts. The 2 parts which are having equal mass, they are flying in perpendicular direction. Both are having 30 meter per second. So here we need to understand what will be the actual mass of these particles. They have given us the ratio, right? 1:1:3 means the masses will be equal to what? If you divide them into 3 parts, means m1 will be 1/5. So one part is that ratio. Total number of parts are what? 1 plus 1 plus 3 will be 5. So 1/5 into 1 kg, that is 1/5 of a kg. Similarly, the second part also equal mass, 1/5 of a kg. The third part, which will be the heavier one, will be what? 3/5 of the kg. So these are the 3 parts. So this 1/5 kg is flying like this. Another 1/5 kg is flying in perpendicular direction. Each of them having 30 meter per second. The third part, we are not given the velocity. In fact, that is what we are supposed to find. So how are we going to find it? We will find it using the conservation of momentum principle. So let us see how we will use the conservation of momentum principle. Now these are 2 parts, 1/5 kg and another 1/5 kg, their momentum will be what? So mass multiplied by velocity, which is what? 1/5 into 30, that will be what? 6 kg meter per second. Similarly, the other one also 6 kg meter per second. 1/5 into 30 will be what? 6. Now these momentum are vectors. They are in perpendicular direction. So if you look at the resultant, let us call them as what? P1 and P2. The resultant of them, since they are equal vectors, right, will be along the angular bisector. Okay, the resultant of P1 and P2, the angle is 90. So what is the magnitude? It will be root of 6 square plus 6 square, that is going to be 6√2 kg meter per second. That is the value, but it will be along the angular bisector. Now the third particle momentum should have equal magnitude but exactly opposite direction. Opposite direction means what? If it is along the angular bisector like this, it should be exactly in the opposite direction, but magnitude must be same. Means third particle momentum magnitude should be equal to what? 6√2 kg meter per second. That's when we add all the 3 momentum, P1 plus P2 plus 3, when we add all 3 momentum, that will add up to 0, because total initial momentum is 0, right? Even after the explosion, the total momentum of the particle should be what? 0, because explosion is internal phenomena, right? There is no external force acting. So the total momentum of the system will be what? Conserved. Initial momentum will be equal to final momentum, which means the third particle, what is the mass of the third particle? Already we have seen. What is it? 3/5 kg. If it's having a velocity v, then the momentum should be having a magnitude of how much? 6√2 kg meter per second. So from here we can see 3 ones are, 3 twos are, 5 will go to the other side, kg is cancelled. So v will be equal to what? 5 into 2 will be 10, 10 root 2 meter per second. So that is what is going to be the velocity of that bigger part, so that now the conservation of momentum principle will be satisfied. Okay, we'll move on to the next question. This is a question that has come in the year 2000. In fact, in one of the previous part videos we have seen a similar model of question. What is it? A body of mass 3 kg hits a wall at an angle of 60. So if you remember the problem, right, so we generally represent the angle as what? Theta. Okay, so here what is the angle? 60, and returns at the same angle. So it is returning at the same angle. The impact time is 0.2 seconds. The force exerted on the wall is how much? They're asking what is the force exerted on the wall. So here if you look at it, the assumption is that the speed of the particle is also remaining same. Means, before the collision it is having a speed of 10 meter per second. After collision also the same speed. The only thing is the direction is changing. Now here when we look at the velocity of the 3 kg body, so we can see here this is the wall. This is the wall, and initial velocity is like this. Now velocity we have to look at it like a vector quantity. So if we look at it like a vector quantity, right, we can take the components of the velocity. So this is theta, means this will be theta. Okay, so here it is having the velocity v, let us say. So first we'll try to solve the question with the parameters, then we'll substitute the respective values whatever they are giving us. Okay, so the velocity is in this direction. So velocity, when we take the components, means what? One component will come like this, other component will. So this side component is what? V cos theta, since it is making an angle theta here. This side component will be V sin theta. So if you want to look at the momentum, right, momentum is what? Mass times velocity. So momentum is like this. Momentum also same. Mv cos theta will be the component along that wall. Mv sin theta is the component perpendicular to the wall. Okay. If you want to represent the momentum as a vector, so we'll consider these directions. Let us consider the right side as what? Positive I. So left side will be what? Negative I. Upward as what? Positive j. Downward will be what? Negative j. Okay. Now what we see here is the momentum, initial momentum, right, can be expressed as a vector. How? You see here, mv sin theta is along the I cap direction. So mv sin theta into the I cap. Mv cos theta is downwards, means minus j. Mv cos theta into minus j. This is the initial momentum. Now we look at the final momentum. This is the initial momentum in the vector notation. Now we look at the final momentum. So final momentum means what? It has to be with the final velocity. So final velocity, the direction is already indicated clearly. So we'll have the wall over here, and this is the normal. The final velocity is in this direction. Here the angle is theta. If you take the components, means this is the final momentum, same value. Magnitude will be same, mv. So this will be mv cos theta. This will be mv sin theta. So what we have is final momentum, right? Its component mv sin theta is along the minus I cap direction. So mv sin theta into minus I cap. Mv cos theta is as it is along minus j cap. Now this body is undergoing a change in momentum. So what is the change in momentum? It is final minus initial, which will be equal to what? Final value minus initial. So we'll see that the mv cos theta into minus j cap will get cancelled. So what we'll have is minus 2 mv sin theta into I cap. This is the change in momentum. Change in momentum magnitude. Magnitude will be equal to what? If you take a modulus of this, means what we are going to get? Modulus of I cap is 1. Minus will not come because modulus is absolute value. So it will be what? 2 mv sin theta. So this is what is the magnitude of the change in momentum for this body of mass 3 kg. And rate of change of momentum, because this change of momentum is happening in the time for which the body is in contact with the wall. What is the time? 0.2 seconds. Okay, so rate of change of momentum will be what? the force acting on the body, isn't it? So what will be the rate of change of momentum? Means change in momentum. Now we'll substitute the values. Change in momentum is what? The value is what? 2mv sine theta. We have to divide this by the time taken. So what is it? 2mv sine theta divided by the time is what? 0.2 seconds. So we'll substitute all the values that are given over here. Okay. So 2 into mass of the body is 3 kg into v is what? 10 meter per second into sine theta. So sine 60 divided by time is what? 0.2. So sine 60 will be root 3 by 2. We can see here 2 will be cancelled. So what we'll have? This is 30 by 0.2 into root 3. So 0.2 can be written as what? 1 by 5. So the 5 will go to the numerator. So what will have? 30 into 5 into root 3. That is 150 root 3. So this is what? The rate of change of momentum for the body of mass 3 kg. That will be the force acting on that 3 kg mass. Now as per the Newton's third law principle, right? Whatever the force acting on the 3 kg mass, 3 kg mass will in turn apply a force on the wall. And that is what they're asking. The force exerted on the wall is how much? So how much it is going to be? Magnitude wise, it will be same as the force acting on the 3 kg mass. So the answer is what? 150 root 3. So we have solved same type of question. So we can remember this result in terms of the general expression. What is it? It will be 2mv sine theta divided by t. So here we should consider the theta is what? The angle made with the wall, and this formula will be when the angle of the direction in which the ball is coming first or the object is coming first with the wall, and angle with which it is leaving, both are same, and initial velocity magnitude is same as final velocity magnitude. In that case we can use this formula. Okay. Next we have a very standard question. In fact, the same model of question has also come in the 2020 paper. Two masses as shown in the figure are suspended from a massless pulley. So this pulley is what? Massless pulley. Okay. The acceleration of the system when the masses are left free. So this is a 5 kg, this is a 10 kg. So when we leave them free, what will be the acceleration? So some people even remember this standard formula. If you consider the masses as m2 and m1, if m2 is more than m1, right? So what happens is this m2 will go down, let's say with an acceleration a. m1 will be going up with the same acceleration. Why? Because they both are connected by the rope. And the assumption is what? The rope will be inextensible. So the common acceleration will be equal to what? m2 minus m1 by m2 plus m1 into g. So this is a standard formula that people even remember. So what is the answer? It will be 10 minus 5 by 10 plus 5 into g, which is what? 10 minus 5 is 5, 10 plus 5 means 15. So 5 ones are 5 3. So what is the answer? It is what? G by 3. So what is the answer for this question? It will be g by 3. That is the acceleration with which the masses will be moving. So 10 kg will move down with that much amount of acceleration. 5 kg will be moving up with the same amount of acceleration. Now we can even go one step back and see how this formula is coming. If we just go one step back, we can see how that formula in fact is coming. So if you look at the pulley and the mass as right m2, so we'll just do the calculation with the general numbers only. Now let us consider that m2 is heavier than m1. So what we'll expect is m2 will go down and m1 will be going up with the same acceleration value. So if you look at the free body diagram of this m2, right? Free body diagram of the m2, it will have its weight and tension force because it is connected to the rope. There will be tension that will be acting always into the rope. So since it is the same rope, right, tension everywhere will be same. Because of them, it is going down with an acceleration a. Means what? The net downward force minus upward force is equal to what? Mass of that object into the downward acceleration. This is the equation for the m2. Similarly, we can draw the free body diagram of m1. So m1 will experience its weight, same time it will also experience tension here, but because of them it is going up, means net upward force. T minus m1g is the net upward force is equal to what? Mass of that object into its acceleration. Both the cases acceleration is same. Now we have two equations. By solving these equations, we can find actually the value of T as well as the acceleration. We can find both the value of the tension in that rope as well as the acceleration. So here we'll just try to get the acceleration, because once we get the acceleration means what? We go to any equation, substitute the acceleration value, we can find the tension. That is how it is going to work, right? Now what we will do, simply let us try and add both the equations. So let us call them as what? Equation 1 and equation 2. We will add both of them. Add 1 and 2. If you add means what is going to happen? Look at this left hand side, right? Minus T is there, plus T is there. Both will cancel. So left hand side we'll have what? Here m2g is there. Here minus m1g. Right hand side we'll have m1a, m2a. So it is what? m2a plus m1a. So here we'll take g common out. m2 minus m1 into g, that is equal to what? Here we can take a common out. m2 plus m1 into a. We are looking for a, right? So let us bring the m2 plus m1 to the left side. It will go to the denominator. So what we'll have? m2 minus m1 by m2 plus m1 into g. So this is the standard. So this is what is our common acceleration. We take the value and substitute in any equation, we can get the tension. But here this question, they are not asking us tension. They are just asking us what? The acceleration with which the objects will move. So this is a standard formula that we can remember. Next we have a question that has come in the year 1998. A mass 1 kg is suspended by a thread. They are giving us two cases. First case is what? Lifted up with an acceleration 4.9 meter per second square. Second case, lowered down with an acceleration of 4.9 meter per second square. The ratio of the tensions is. So look at it, what is going to happen? So we are suspending the 1 kg mass with a rope. First case, what we are doing, it is lifted up with an acceleration of how much? 4.9 meter per second square. Second case, same setup, it is lowered down, means downward acceleration. Now by looking at this number 4.9 itself, we should be careful that in this problem, if we are using g means, we should take it as what? 9.8 meter per second square, because we see the numbers basically in this question. Of course they didn't give us what is the value of g, but if we take it as 9.8 means there could be a chance for the cancellation. Okay, now look at it. So this 1 kg block, it will have its weight. Weight means what? 1 kg into g, which is what? 9.8, right? Which means 9.8 newtons will be acting downwards. That is the weight. And there will be tension. It is going up with an acceleration means what is the relation? Let us call it as T1. So T1, upward force minus downward force, 9.8 is equal to what? Mass of the object into acceleration. 1 into 4.9 means it will be 4.9. So T1 is equal to what? The 9.8 will go to the right side. Minus becomes what? Plus. So 9.8 plus 4.9. How much it is? It is 14.7. So that is what is the T1 value. Now we'll come to T2 case. Look at this. Here also same weight. Nothing is changing. But it is going down. Means what? Downward force, which is 9.8 minus T2 is equal to what? Mass of the object is same 1 kg into acceleration is 4.9. So it will be what? 4.9. From here we will rearrange means 4.9 will come to the left side. It will become minus 4.9, right? What is 9.8 minus 4.9? That is again 4.9, because 4.9 into 2 is what? 9.8, right? So which means T2 is what? 4.9. They are asking what is the ratio of the tensions. Means they are asking what is T1 by T2, right? You have to take the same order. Okay, so first case is what? Lifted up. So 14.7 by 4.9. 4.9 ones, 4.9 threes. So what is the answer? It will be what? 3:1. Option C is the right answer. It's a straightforward question. The only thing is we have to look at both the scenarios carefully and be able to get the answer. Next we have another interesting question. Probably these kind of questions may not be coming in the recent years. Why? Because this question has got some application of the integration principle. Okay, so if you look at the questions erstwhile, right? Like in early 2000s or 1990s, we used to have good number of questions coming on the application of integration, etc. But recently we see that since some of the students are aspiring for NEET, they would have pure bio, which means they will have the +1 +2 without math. So they will not have exposure to integration and differentiation, things like that. So that is the reason why we will see that most recent year papers, right, we have very less focus on these integration, differentiation, application based questions. So look at this. A bullet is fired from the gun. The force on the bullet is given by, it is a variable force. We can clearly. What is the force value? 600 minus 2 into 10 power 5 into t. Okay, so the t is only multiplying to the second factor. So what? 2 into 10 power 5 into t. Okay, the t is not multiplied to 600. Where F is in Newton, t is in seconds. It's a variable force. The force on the bullet becomes 0 as soon as it leaves the barrel. So as the bullet is leaving the barrel, the force becomes 0. What is the average impulse imparted to the bullet? They're asking what is the average impulse imparted to the bullet. Okay, what is impulse? See, in general, when we talk about impulse, right, impulse is measured as what? Force multiplied by the time for which the force is acting on the object. So this is also quantified as what? Change in the momentum. So this force multiplied by time will be useful when we have a constant force. So if we have a constant force of, say for example, 5 Newton acting for 2 seconds, simply what we'll do, 5 Newton into 2 seconds, that's it. That is what will be the impulse. But here the force that we have is a variable force. So here what we need to do is, if say for example the force is acting for a time t, then at each and every time value the force is changing. So we'll have to take the differentially small impulse for a time dt. That is what? F multiplied by the small time interval dt, and we integrate it between the limit 0 to t. What is this t? This is the final time until which the force is acting. So this is what is going to give us the impulse. Okay, so that is the reason why this is an, so we are not able to do just directly force into time. Why? Because here the force is not a constant value. So what are we doing? We are taking a small time interval dt, differential time is what we call it as, multiply that with the force, you will get small impulse. That we have to integrate this expression between the limits 0 to final time. Final time means what? The time up to which the force is acting, right? So what they are saying, the force on the bullet is becoming 0 as soon as it leaves the barrel. Means we will try to find that time. No, we'll equate the force to 0, because they are saying what? The force is becoming 0 as soon as the bullet is leaving the barrel, right? So we'll try to find what is the time when the bullet will leave the barrel. So we'll equate the force to 0. 0 is equal to 600 minus 2 into 10 power 5 into t. So we'll rearrange. Minus 600 is equal to minus 2 into 10 power 5 t. Minus minus is cancelled. 2 ones are 2 300s. The 10 power 5 will go to the denominator. So 300 by 10 power 5. That is the time, which is what? 3 into 10 power minus 3. So this time is in what? It is in seconds. So we have to integrate from 0 to this amount of time. Okay, so we'll just keep it aside. Now we'll just have to carry on with the integration steps. So for now what we'll do is we will call, so this is the time that we have to keep in record, because this will be used in the final step of the integration. Okay, so what is the time? Let us call it as what? T naught. T naught value is what? It is 3 into 10 power minus 3 seconds. Okay, now we'll integrate it from 0 to t naught. That is the final time up to which the force is acting. Okay, so look at it. Integral 0 to t naught f dt, right? F is what? 600 minus 2 into 10 power 5t into dt. We'll split the integration. 0 to t naught 600 dt plus integral 0 to t naught minus 2 into 10 power 5 t dt. So this is what? First term 600 into integral 0 to t naught dt. Second term is what? Minus 2 into 10 power 5 integral 0 to t naught t dt. Now here we should have some familiarity with the integration, the standard integrations, right? So while we say that in NEET we may not get questions on the applications of integration and differentiation, but still if at all there are questions like this, right, we should be ready to tackle them. So I'll erase the upper part so that we can do the concluding steps. Now, you know, the standard integration, right, integral dt will be what? T. Integral dt will be what? T. So 600 t between the limits 0 to t naught minus 2 into 10 power 5. Integral t dt will be t square by 2. T square by 2. This also limits. Limits means what? Always it will be the final limit value minus initial limit value. 10 power 5 final limit value minus initial limit value. So what is it? 600 into t naught, right? T naught is what? So 600 into 3 into 10 power minus 3 minus 2 into 10 power 5. T naught square by 2 means what? If you square it means it will become what? 9 into 10 power minus 6 by 2. 2 is cancelled. So what do we have? This is like 600 into 3 is what? 1800 into 10 power minus 3 means it will be 1.8 minus 10 power 5, 10 power minus 1 will remain 0.9. That is what? 0.9. So the impulse, right, will have units of Newton into second, because it is what? Force multiplied by the time, right? Impulse will be having a unit of Newton into second. So what is the answer for this? The average impulse will be what? 0.9 Newton into second. So where is the answer? It is option D. So while solving these integration application questions, we should be a little bit more careful. They do take some time. Most of the cases, right, they will take some time. But if you are careful enough, then these are the questions where you can show some differentiation from the other students. While most of the NEET aspirants, right, they will be lagging behind when it comes to these kind of questions. So if you're able to bag marks in these questions, means you will definitely be able to edge over them. Next, we have another standard and repeated model question. This has come in the year 1998. In fact, no, we have seen same question, but in that question they have asked us a different quantity. A mass M is placed on a very smooth wedge resting on a surface without friction. So you can see there is a mass M. So here it is what? Smooth. It's resting on the wedge. Once the mass is released, so once you release the mass, what is going to happen is, we know there will be a component of the weight acting on the mass which will try to make it slide down the wedge. Once the mass is released, the acceleration to be given to the wedge so that the mass M remains at rest is A. Okay, so we need to find what is the value of this A. So let us try to understand the question carefully. So what they are trying to say is that when you give the wedge an acceleration A, horizontal acceleration, because the wedge will be given horizontal acceleration, this mass M will remain at rest. Means what? When this mass M is also moving horizontally with acceleration A, it means what? Both will have the same acceleration. So the mass M will appear to be at rest, isn't it? So the condition is what? What is this horizontal acceleration that should be given so that the mass M will not slide? The mass M will not be sliding. That is the question here. So when you look at normally this mass M, right, when we want to understand the motion of the mass, we will try to resolve the forces acting on it. So this is the theta. Theta is the inclined plane angle. What will be the force acting on it? There will be a weight and there will be the normal reaction. Generally what we do is we will try to resolve the components into along the plane, normal to the plane. Whenever we have an object on the inclined plane, right, we will try to resolve the forces into what? Along the plane and then normal to plane. But in this case, since the motion is supposed to be along the horizontal, the mass M is just supposed to have an horizontal acceleration A, right? We will try to resolve the forces into same, like the way normally we do, horizontal and vertical. So here the mg is already vertical, no need to resolve it. Now if you look at this line, right, this is a normal line. whatever is the inclined plane angle, the angle here also will be theta. Now look at it, this is theta, means this also will be theta, vertically opposite angles. So the normal reaction can be resolved. N cos theta will be vertical and n sin theta will be horizontal. Now when we say that the mass m is only moving horizontal, it's not sliding, means what? There is no vertical motion at all. Means vertical, there is a balance. Balance means what? N cos theta is equal to mg. So in fact, the other question that we got right is basically asking us to find this n value. In fact, in that problem, right, if you probably recall that from the previous videos, we would have said that the n value will be equal to what? Mg by cos theta. That was the answer for the previous question. So vertical, there is a balance. If you look at horizontal, on the mass there is only one force acting, which is n sin theta. That should give it the acceleration a. Means what? N sin theta should be equal to what? M into a. So let us look at both these equations, equation 1, equation 2. Here we don't need n value. We are looking for the a value, right? So what we will do? Let us do equation 2 by equation 1. Means left hand side is what? N sin theta, n cos theta. N is cancelled. What we will have? Sin theta by cos theta. Right hand side is what? M into a divided by m into g. M will be cancelled. It is what? A by g. Sin theta by cos theta means what? Tan theta, right? So a by g is equal to tan theta, which means a is equal to what? G into tan theta. So if you give this acceleration to the left side, if you give this much amount of acceleration to the left side, right, then what is going to happen? The block M will remain at rest with respect to the wedge. So what is the answer for this? It is option A, where the entire system is given an acceleration A, which is equal to g tan theta towards the left side. Okay, so this is an important model of question we have seen in other problem also, where of course they have asked us a different quantity. In the other question they have asked us what is the value of this normal reaction. That question the answer was normal reaction will be equal to what? Mg by cos theta. In this question they are straight away asking what is this acceleration which must be given. There is another question, straightforward, 1997 this question has come. A force of 6 Newton acts on a body which is at rest, mass 1 kg. During this time, the body attains a velocity of 30 meter per second. So initially, so what is the initial velocity? Initial velocity is what? 0. Final velocity we are looking at is what? 30 meter per second. The time for which the force is acting on the body. So let us look at what is the acceleration produced. We are saying there is a 6 Newton force acting on the 1 kg body, right? So what is the acceleration? 6 Newton by 1 kg. What is it? 6 meter per second square. That is the acceleration. Initial velocity is 0. Final velocity should be what? 30. Acceleration is 6 meter per second square. They are asking the time for which the force is acting on the body, because that is the time in which our velocity is changing from 0 to 30 meter per second, right? That is when the acceleration will be acting on the body. Okay. So what is the time? We know the initial velocity, we know the final velocity, we know the acceleration. We just have to find the time. Okay, what is the relation between them? Since it is a constant acceleration or uniform acceleration, we have the equation, right? V is equal to what? U plus AT. So V is what? 30 meter per second is equal to U is anyway 0. A is what? 6 meter per second square into T, which means what? 30 meter per second divided by 6 meter per second square is equal to T. What is it? 6 ones are 6 5s are. What is the time for which the force must be acting on the body? It is what? 5 seconds. So that the velocity will be changing from 0 to 30 meter per second. Next we have even more straightforward question. A force 10 Newton is applied on a body to produce an acceleration of 1 meter per second square. What is the mass of the body? Okay, I think it can't get simpler than this. So what is the relation? Newton's second law, straight application, right? F is equal to what? M into A. So M is what? F by A. Force Force is what? 10 Newton. And the acceleration produced is what? 1 meter per second square. Newton is what actually? Newton is what? Kg into meter per second square, right? So the meter per second square is cancelled. What is the unit? The mass will be in the SI unit, which is kg. So what is the answer for this? It is option C. Next, we have another question based on the Newton's second law application. A force vector applied on a mass is represented by, what is the force vector? They are giving the force in the vector notation, 6i minus 8j plus 10k, and is accelerating with 1 meter per second square. What is the acceleration value? They are giving us the acceleration magnitude. Force they have given us in the vector form, but acceleration they are giving us only the magnitude part. Okay, what is the magnitude of the acceleration? 1 meter per second square. What will be the mass of the body? From here we need to find what is the mass of the body. So let us say we don't know what is the mass, right? So let us say m, because everything is in SI unit. Let us take mass to be in kilograms. Okay, so m is what? M is the mass of the body. Okay, so if m is the mass of the body, then what will be the acceleration vector? Force vector by mass, which is what? 6i minus 8j plus 10k by m. Okay, now we can split and write it. What is it? 6 by m into I minus 8 by m into j plus 10 by m into k, like that we can write. Now this is the acceleration vector. What about the magnitude? Means any vector, what is the magnitude? I component square plus j component square plus k component square. That is the acceleration magnitude, right? Which is in this case given as what? 1. So look at it. What do we have? Denominator m square is common. 6 square plus 8 square plus 10 square. So we'll have what? Root of, this is 6 square plus 8 square is 100 plus another 100, root 200. Root of m square is what? M. So we'll take the other side, which will give us what? Root 200 will be equal to m. What is root 200 means? 10 root 2, and unit must be kg, right? So what is the answer for this? Option C. All that we are doing is what? Just getting that acceleration in the vector form and then applying the magnitude formula. That's it. So this is another standard question based on the recoil velocity of the gun. So in this part, right, between these years, because if you see the video, the way we made it, we have made that, the questions are coming in the order of the years. But some of the questions are related to the rocket propulsion. We have taken them aside and we'll discuss them in the next part video. So we want to discuss all these rocket propulsion questions in one place. Okay. So man fires a bullet. What is the mass of the bullet? 200 grams at a speed of 5 meter per second. The gun is of 1 kg mass. What is the mass of the gun? 1 kg. By what velocity the gun will rebound back? That is what is we call as the recoil velocity. So if you look at it, right, let us say the bullet is having a mass small m and gun is having a mass capital M. Bullet velocity is v. The recoil velocity is vr. Now initially the bullet is inside the gun, and the total momentum initially before the bullet is fired, total momentum will be what? 0. And the firing of the bullet will happen because of the internal phenomena. The trigger firing, right, will happen because of internal, which means what? No external force. So there will be no external force acting on the bullet or the gun. The triggering mechanism is inside the gun. So no external force means what? The momentum should remain constant. Now once the bullet is fired, it is having a momentum of what? M into V. As a result of this, we are saying the gun also will get a velocity which we are calling as what? The recoil velocity. So what about the momentum of that? M into Vr. In fact, these are what? Vectors. Velocities are what? Vectors, right? So total final momentum also must be what? 0, because initial momentum should be equal to final momentum, which means look at this, small m into V is equal to what? Minus capital M into Vr. So from here, minus small m by capital M into V, that is what is the recoil velocity of the gun. So here the minus symbol indicates that if the bullet is moving in the forward direction, the recoil will be in the backward. That is what is the significance of the minus. But just we are looking at the magnitude, means the recoil speed will be equal to what? Small m by capital M. Small m is the mass of the bullet, divided by capital M. Capital M is the mass of the gun. Small m by capital M into V. V is the velocity of the bullet. So this is the formula that we can remember. I'm sure a lot of us remember this formula. So what is the answer? The recoil speed of the gun will be equal to what? Small m, mass of the bullet. So here we have to be careful. Mass of the bullet will be generally small. It will be in a different unit. You can see here it is what? 200 grams, means what? 0.2 kg, divided by what is the mass of the gun? 1 kg, into what is the velocity of the bullet? 5 meter per second. So 0.2 into 5 is what? It will be 1. That is what is the recoil speed of the gun. So what is the answer for this? It is option A. So we can remember this formula for the recoil speed or recoil velocity of the gun. Next we have a straightforward question based on object on an inclined plane. A block has been placed on an inclined plane with slope angle theta. Theta means what? That is the angle of the inclined plane. So if you have the inclined plane like this is the angle. The block is placed. Block slides down the plane at a constant speed, means it is sliding down at a constant speed. The coefficient of kinetic friction is equal to. So here none of the information is given about the block. So let us consider that mass of the block is m, and we know that this should not be coming in the final answer because we are assuming it. Okay, so look at it. There will be weight acting on that block, and of course there will be the normal reaction. So since we're talking about the motion of the block along the plane, generally already we have said in one of the previous question also, we will resolve the forces into what? Along the plane and perpendicular to plane. Already the normal reaction is perpendicular to plane, so weight has to be resolved. So this angle will be theta. Mg cos theta will be perpendicular to the plane downwards. Mg sin theta will be along the plane downwards. In fact, this is the force that will make the objects to slide down on an inclined plane. But since there is roughness, because they're talking about the friction concept, right? As this mg sin theta is trying to pull the block down the plane, there will be a friction that will be acting upwards, up the plane. And since there is a motion, means what? It is the kinetic friction. What is the kinetic friction value? Mu k into the normal reaction. So first, perpendicular to plane, there is a force balance, no movement. Movement is only along the plane, which means what? The normal reaction value is equal to what? Mg cos theta. So the frictional force, kinetic friction, is equal to what? Mu k into mg cos theta. Now they are saying that the block is sliding down the plane at a constant speed, means what? The component of weight down the plane, mg sin theta, should be exactly balanced by the friction. Then only the block will be sliding down the plane with a constant speed, correct? Which means what? Which means this friction force value, mu k into mg cos theta, should be exactly equal to what? Mg sin theta. Means mg is cancelled. So which means what? Mu k will be equal to sin theta divided by cos theta. The cos theta will come to this side, denominator. What is it? Tan theta. So they are asking us what? The coefficient of kinetic friction, right? What is the value? It is nothing but tan theta. Option D is the right answer. Okay. Next we have another question based on the tension in the string. A monkey is descending from the branch of a tree with a constant acceleration. Descending means what? It is coming down. If the braking strength is 75% of the weight of the monkey, braking strength means what? We are talking about the braking tension in the branch. So we consider the branch to be like a rope, okay, on which this monkey is basically descending. Okay, So the breaking tension in the branch is what? 75% of the weight of the monkey, means what? 75 by 100 into what is the weight of the monkey, means mg, which is what? 3 by 4 mg. This is the breaking tension in the branch. The minimum acceleration with which monkey can slide down without the branch breaking, basically. So without the breaking of the branch, what is the minimum acceleration with which the monkey can slide? So look at it. When the monkey is sliding down, means it is sliding down with an acceleration a. We have to find what is the minimum value for this. We have to find what is the minimum value for this. Now look at it. What is going to happen when it is sliding down? There will be, of course, tension force acting on the monkey and the weight of the monkey. Now it is going down with an acceleration, means what? Net force must be downwards. So what is the balance? Downward force minus the upward force tension is equal to what? Mass of the monkey into the acceleration. Now look at this relation. As t is increasing, because we are subtracting t from mg, right? As t is increasing, what is going to happen? A will decrease. But t cannot increase forever, right? Because there is a breaking tension for the branch. Means tension is more than this value, means what is going to happen? The branch will actually break. So the maximum value of tension possible will give us the minimum acceleration for the monkey while it is going down. Okay. So which means what? mg minus 3 by 4 mg. A minimum. That is what it will be giving us, the A minimum. So on both sides the m is cancelled. So g minus 3 by 4 g is what? That is g by 4. So the minimum acceleration with which the monkey can slide down safely without breaking of the branch is what? G by 4. What is the answer for this? It is option C. So we have seen, I think in the previous part video, we have seen a question where the monkey is climbing up. Okay. So this is about this part video, and we will see in the next part.